thing back here. Okay. When you think of a data pipeline, what do you think of? Right? So a set of data processing elements connected in a series where the output of one element is the input of the next one, right? Why would we do that? Why would we connect a series of data processing elements? Repeatability? Yep, that's the key thing. How do they build cars? Assembly line, right? So this one area is really good at attaching the engine, right? And this one area is really good at putting the hood on, right? And they're dependent. I really can't put the hood on until I put the engine in, right? So what does that give me? What does an assembly line give you? It gives you consistent quality. It gives you a consistent product, and it gives you expanded throughput. For instance, if it takes 24 hours to make a car, right, I can make 10 cars in 24 hours by having 10 lines of work, right? Does that make sense? So a data pipeline is key in a lot of areas. So if you are processing data and you want that data to be consistent, well-designed, in a place, in near real time, and quality so that I can build upon it, your data pipeline is your solution. I kind of talked about this, but basically, this is what it is, right? It's reproducible. It's a set of components that I could potentially reuse. It's a consistent way of managing data. It's designed. The data pipeline should be designed for scalability, right? So whether I have 100,000 pieces of data going through my system at one time or 10 million pieces of data, the system should be able to flex and manage it, right? I think this is interesting, but this last part, right? You will define what, where, and how data is collected, transformed, and loaded. Okay? But at the end of it, after manually picking every field, every data source, every transformation, is that you can have it all automated, right? So I've got 5 pieces of raw data, and I have this analysis, right? I've got to take this raw data, and I've got to turn it into something that can be analyzed, right? I got to clean it, I've got to transform it, I've got to link it, I've got to do all this thing, right? And then I get this analysis. So then you get a new analysis come down. Do you want to start with the raw data again? Or you want to start over here where 60% of your time was transforming, preparing, cleaning, right? So what it begins to do is it begins to give you the foundation, right, for meaningful analysis in a timely manner. Questions about that? Thoughts? How many people out here has a data pipeline? Okay. What do you guys use?
Stream sets, Kafka.
I'm sorry?
Kafka, stream sets.
Stream sets. You like stream sets?
I don't know since I don't personally work with them. But
Okay. Yeah. I had lunch with Kenyatta over here, and he's looking at data pipelines. Stream sets he thought was pretty cool. I did not include it in my review of products, mostly because I hadn't heard of it at that point. But I've heard good things. Who else? Who else has a data pipeline? Now that you know I'm going to call on you, your hands don't go up. You said you had one, right?
Primarily Python using APACHE.
Okay. Okay. All right. Has it made a big difference? Do you find that you can build and quickly deliver analysis because of it? Yeah? Yeah? Okay. All right. So I work at Sonic, right, and we use Spark structured streaming, and we've been working on it for a while, and we're starting to see that value happen, right? I wouldn't say that I'm super pleased with the value we've accomplished at this point from our data pipeline, but I think the real potential is there. It also gives us a consistent way of how we import and manage and prepare data for analysis. R for work, right? Yeah. So when we started this, and this was probably, I don't know, 8 months ago I did this, so my opinions have changed, and we'll discuss that later on. But I did this analysis on these 4 candidates, and we'll explore them, and then I'll show you my evaluation and discuss it. But I want you to get a feel, right, for what a data pipeline could and couldn't be, right, and maybe what you need. So, if that makes sense. So, Frank, I just announced your meetup. Frank, say hi. So he'll be doing the scikit learn Python thing. Why would people go to that?
Because they want to learn how to, if you're a Python guy, you want to learn how to be a Python person, you want to learn how to put machine learning in your project.
Okay.
Super simple and highly effective way to do it.
Okay, fantastic. Okay. So has anyone explored any of these as a data pipeline? Has anyone looked at Spark structured streaming, Apache NIFI? Okay, you have? Yeah.
We looked at NIFI and Cloud Data Flow.
Cloud data flow. Okay. Did you?
Yeah, we looked at NIFI before deciding on Kafka.
Okay. Oh, that's interesting. So, so Streams is outside of NIFI. It would be an add-on to NIFI.
Well, we didn't use it.
Okay. 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 All right. So, what is Spark structured streaming? Does anyone use Spark? Yeah. Spark is an effective way of using data on a bucket or like HDFS or S3, or just on a hard drive, right? Assuming that your data fits comfortably on a hard drive, and applying a SQL engine on it, right? And it's a very popular, very effective tool for both transforming and machine learning on your data sets. What Spark Structured Streaming has done is they've said, we're going to stream data, right? So where Spark SQL is pretty much batch. Here's a set of data. Here's the transformations I want. Here's my output, right? Here's the predictive model I want to apply. Here's my output, right? That happens one time, right? And then you have to ask it to do it again. What Spark Structured Streaming does, it says, watch this area, and it can be Kafka, or it can be some file system. Watch this area, and as data occurs, right, process it, right? The beautiful thing about Spark Structured Streaming, and the thing we love about it, is that it's using the Spark SQL engine, right? It's a very, very powerful engine for transforming, enhancing, improving, querying, aggregating, that kind of thing, right? The beauty of Spark Structured Streaming is it's running all the time, continuously. So it creates these unbounded tables, these concepts of unbounded tables. And we'll just take a quick look at that. So as data comes in over time, it's basically added rows to the table, right? And then I apply some type of RDD-based transformations on it, and then that results in my data set. And it manages the growth of that data set, whereas if you've ever done Spark, right, you have a data set you've created, it's almost impossible to append to a data set you created before, right? This automatically appends for you and manages it as an unbounded table. If it dies, right, it's checkpointing. What that basically means is I've looked at all these files. I know I've processed these files. I've not processed these files, right? And nothing goes onto your output that hasn't been effectively processed. So if you've used Storm, right, you get like, you put in 500 rows and 800 come out, right? Like, what? What's going on? Like, are they just making data up, or? So, it's like the opposite. I guess that's where all the socks go into Storm. So it comes out, but it guarantees one-time delivery. It's fault tolerant, and when it goes down, it knows where to start back up. I will give you this information. We create a lot of small files in S3, which is a bad thing. And what we're beginning discovering is, as we create thousands of files a day, that turns into millions of files lookups every 15 minutes. And S3 charges you, right, for a listing, right? And that's kind of what we're doing. We're hitting the head. Tell me what this file is. When time was look. They look at the checkpoints. That's okay. So it is something to consider, right? That you will have this I/O every time you do this. Does that make sense? Any questions about it? So, it's a very powerful tool for continuously streaming data, right? Does it connect data nodes in a specific way? Right? No, right? Unless you code it that way in the code, right? It's not clear. Now, it has no problem with, I build a structured stream here, and it goes from this point, transforms it into this point, and I can put another structured stream here that watches that endpoint and puts out another endpoint. It can do that, right? But it's not, you'd have to go into the code and look around, and if you have 30 or 40 nodes, it gets complicated. It's not clear, right? So there's some real maturity here. It was in alpha when we started using it, like a year ago. They've had like 2 deliverables, like 2 production. And there's some limitations to also what you're doing. For instance, we have a stream of raw events from one of our mobile apps, and it needs to join with another one to get a full picture of what's going on with the raw events. You can't join 2 streams, right? I can only join a structure to a stream. Now they say that's coming out, but that's the problem with Spark structured streaming, is you get into it and you're like, okay, let's do that, because that's possible in Spark. And you're like, oh, I can't do that in Spark structured streaming. Right? So this is a risk with it. But if you love Spark and you know Spark, it's your fastest way to a sort of continuous deliverable stream. So I've not used Apache NIFI, but from what I can see, I really like it. I like aspects of it. I like the fact that I have a visual creation, right? I have a clear definition of this data goes here to here to here, right? It says it's inherently asynchronous, so lots of input and output, highly concurrent. So basically I create a node, right? This is my node, this is its input, this is its output, and then I have to put code in the node, right, to perform some action. Right, so that makes me a little nervous, right? Now one of the nice things about the node is it can use Spark, right? So I can get some of this really cool Spark SQL stuff, right? It's not a structured stream, it's kind of executed, but also, so the way it expands and does large sets of data is it can run multiple of those nodes, right? So I have node A, and it's running 15 times, right? So which is pretty nice if my data can be divided and worked on into 15 different places, right? But if I have to take my data and cross-reference it, right, across those 15 different places, then it becomes a problem, right? At that point, I have to dump it into some storage area as a single item and then process the whole single item, right? So that begins to be a problem. So if I'm writing Groovy, running in a small Java process, right, that may literally limit my ability to read that whole large set of data, right? So that would be why I'd run Spark, right? But then you got to manage that, right? You've got Groovy developers and Python developers, and Scala developers, and then you got a mess, right? So it's a very powerful tool, right? But its power can get you in trouble, I think. What did I find interesting? The resource-constrained connections make critical functions such as back pressure and pressure release very natural and intuitive. What? What are you talking about? I have no idea. And this really limits my ability to understand NIFI. Has anyone understood that? Did anyone go, oh yeah? Hopefully next month, Travel Stop says they're going to come and speak, and they're using Apache NIFI. So that's my first question. Tell me more about how it releases back pressure. I'm going to sound really smart, right? So don't steal it. Don't be stealing my thunder. So, but I put that there so that you would be interested. So the architecture is pretty straightforward. You've got a flow controller. The flow control manages processes and expressions. And then it has a repository for executing it, right? So as work comes in, it starts up the right processes and processes them. So how does it do that? Right, and I'm asking this question. I couldn't find where it said that it supported Yarn or Mesos. Does anyone know? I was curious if anyone knows. Did you guys know when you looked at it? I looked for it, I couldn't find it. I get the impression Apache NIFI does its own thing. It does use Zookeeper. I did determine that to manage multiple processes. So if I'm starting 15 processes, Zookeeper knows the 15 are up, and if one goes down, it knows to start it. So I think it manages itself, as opposed to Yarn or Mesos or what is it? Kubernetes? Kubernetes. But this is the thing that makes me go, maybe Sonic should have used Apache NIFI. Oh, I'm sorry, I'm getting out of the picture already. Sorry. It's this graphical interface of how the data flows through my system and the ability to put components back in, right? So if I create a component, I can use it in different flows, right? So if I make a generic component of, hey, let me read in this JSON data, apply a schema to it, and make sure all the key names don't have spaces or dashes in it, right? So that we were actually having that problem right now. We fixed it in a specific way. And then I have to reuse it sort of within the functional programming if I want to do reuse. Whereas this, I would actually have a node, right? And it would do the reuse for me. And NIFI would scale it for me. Does that make sense? So I really like this aspect of NIFI. Any questions? Comments? Anyone's like, oh yeah, Apache NIFI. No? Okay. Does anyone use Spring? You're the only person who's used Spring?
You said use Spring. Use Spring.
Yeah.
Spring data flow.
Spring, yeah, not Spring Data Flow. Anyone use Spring? Anyone? Spring Boot? Never create microservices with Spring Boot? Oh, that's, okay. All of you leave. I'm tired of you. No, it's easy. It's a really powerful tool in the Java community. It is, like, it's really hard to find anyone writing Java code today that's not using Spring Boot or Spring in some way. Unless you're using Spark, because Spark and Spring don't get along. But it, what it does is the Spring Cloud Data Flow gives you this data flow server. And what a data flow server is it manages data flowing through a series of Spring Boot applications. And a Spring Boot application is basically a microservice, right? So basically what Spring Cloud Data Flow is those of you who are building microservices with Spring Boot and Java, this is a good way of building a data platform and a data pipeline because it's using technology you already use, right? You're comfortable with it, you can build it quickly. What would you think the downsides are? Java? Java's the downside? Why do you say that?
As a Java developer, it's quite cumbersome sometimes.
Yeah. And Java 8? I don't think it made it better. Okay, that's a good point. What about data size? So big data platform, microservices. Does anyone see an issue there? Right? I found that Spring Cloud Dataflow had the same issue that I had with Apache NIFI, right? So I create this microservice, this microservice architecture. I create this microservice that does this A, right? And if I need 30 A processes running, the Dataflow server will manage that for me. But that means my data must be able to split into 30, be processed into 30 different locations, and come back together, right, into a single location. So that means that my data can't be aggregated this way, right? I would have to dump it into S3 or some type of bucket and then aggregate it later, right? And it has to fit within a microservice if I'm going to aggregate it, right? So it begins, that concerns me. Now, maybe there's ways around it. Maybe your microservice can kick off a Spark job. That would be fine. But that would be something you'd have to address, right? But if your data works well with this, and you have this technology already, and you're doing it, it's actually pretty nice. It has the graphical interface. It has a really nice management flow. It has a DSL. Right? It works several ways, right? Spring Cloud Dataflow will run, long-lived, right? Looking at data, pulling it in, processing it, outputting it. It also runs in a batch mode, right? Run this data, now we're done. You describe how you want it to flow, and then it manages it. The nice thing about it, I don't know if I put this, let me just put that there, is that it works with almost anything. I'll go back to those two slides. It works with almost anything, right? It works with Cloud Foundry, obviously pivotal, right? It works with Yarn, Mesos, a Kubernetes thing, and anything you can define. So for instance, what's the value of Yarn? Does anyone know? Right, and Spark offers this too. Yarn says, hey, I know about all these machines. I know how much memory these machines have. I know how much the processing power is. And I'm going to divide that up and share it across demands for it, right? So for instance, I have a 40-node cluster. Yarn's running on it. I've got Dataflow saying, hey, Yarn, give me this data. Give me these resources. And then the Yarn gives it to them, and then they execute it, right? So this cluster management of resources, this cluster operating system, which Yarn, Mesos, and some of these other guys offer, right, is used within Spring Cloud Dataflow. Okay. I think we went over that one, didn't we? Again, we talked about the microservice architecture style, and that can be really nice, right? Talked about the microservice applications, whether you run many in parallel to scale. And then it integrates well with the Spring's health checks, security, configurable logging, monitoring, jar packaging. It works well in that environment, right? If you're already using Spring Security and you're already using these types of things, it can be really valuable. But again, I lose that RDD concept, that management of large data sets across multiple processes that knows how to aggregate and group it together. Okay. Has anyone looked at AWS Glue? No? I really like this tool in some ways. It claims to be pretty much an ETL tool. The thing that I like about Glue, and the reason I'm presenting it, is partly because of the data catalog, right? If you have a data pipeline, and you begin processing hundreds of tables, resulting in 50 or 60 resulting tables, how do you keep track of it all? How does how does Frank come into my system and know how to use those 6 tables of the 50 that we have? How does he know how to find those 6? How does he know what's in them? How does he know who feeds them? A data catalog, right? We're actually looking at Waterline as a data catalog, but Glue has a data catalog built into it. And we'll kind of discuss what it does. This will be an important part of your data pipeline as it matures. How do people find your data, and how do they use it, right? So, first thing you do in Glue is you build a data catalog. Now, Glue is not a sophisticated data cataloging tool, right? What it really does is it builds a Hive meta catalog, right? Which can be used by Redshift Spectrum, AWS Athena, AWS EMR Pesto, I'm saying that wrong. Presto, thank you, which is from Facebook, or of course Hive, or Spark SQL, right? So basically what I'm doing is, here's some data on S3. Within the catalog, I describe it, or I send a crawl around that figures out what it looks like, right? So if it's JSON or Parquet, it can figure out the structure on its own, right? And I put it in the catalog. And if I want to query that data in S3, I have multiple tools available to me, right? Redshift Spectrum, AWS Athena, and almost everything in EMR, right? Presto, Hive, Spark SQL, or anything that can read a Hive catalog. So it's really powerful. Also, the crawler will change the catalog description when you change it. You add a column, you take away 2 columns, the crawler will find it and correct it. So it's pretty cool, right? So I've got this living catalog. So anyway, you build your catalog, and then you write a series of Python that runs in PySpark, right? Using the RDD Spark concept, and it transforms your data into something else that then, of course, goes into your data catalog. Right? It's not necessarily a full-blown pipeline tool. It's more of an ETL management tool, which is a lot of what you're doing with a pipeline anyway. The thing with Glue, and this is one of the key reasons we didn't go with it, is that it's really a batch job. It's not a streaming job. It's not really working in near real time, right? So I schedule it and it runs, right? And we'll talk about event-based here in a minute, but basically that's what it does, and it runs Python RDD to do the transformations, and it uses the catalog, the data catalog, to make it available, right, for all your applications, right? So let's say you want to analyze log data, all right? So you got this app out there. It's putting that log stuff into Glue, into the bucket, right? Glue comes along and says, I know what that log data looks like because I've defined it. I transform it with PySpark, right? I then put that into Redshift. I record it in CloudWatch, and then I can do analysis on it once it's in Redshift. Right? Pretty straightforward. Again, I get a unified data across multiple data stores. Now, if you're in AWS, who's in AWS? Yeah? Okay. Just the cool table? Maybe you should move, man. You can use the Glue data store, right? You don't have to use the ETL part of it. You don't have to write the Python, but you can say, here's data sources in S3, make that available within Glue, and then all the Amazon services will know to use the Glue Hive meta catalog. So you can use this data catalog and use Spark Structure Streaming, use Apache NIFI, whatever you're doing, as long as you're putting in S3. Again, just transforming S3 data so that it can be used elsewhere, right? So I go and I've got a set of data. These crawlers are executing it, right? I got the data catalog, and then I've got all these resources, right? Pretty straightforward. So basically what I'm doing is I'm applying a structure, a description of structure around data that's in S3. Okay. One thing it can do if you add a lambda is lambda can be event-based, right? A file appeared in this bucket. Something happened on Kinesis, right? I guess you can probably watch Kafka if you can write that. And then it basically says, hey, execute that glue job. Right? So you can be event-based. It's not really near real time, but you could theoretically do something very similar to Spark Structure Streaming in watching a bucket or some type of directory and then processing the data as it comes in. The problem is the checkpointing, right? If it fails to process some data, like it doesn't know it, right? So there's potentially missing data. Okay, so we evaluated this. I don't know why the font's white. Maybe I should have checked that last night. On a lot of things, and I'll show you real quick. It's 4 slides long as to what I measured it against. Right. One is we wanted it real time. Right. And I felt like Cloud and NIFI and Spark Structure Streaming did that. Right. How important that is to you, you need to evaluate. Right. Is the stream sets, is that real time? Okay, all right. Manages the upgrading of the data, right? So for instance, if I'm going to modify the data in some way, how does my system manage that? The other one is manages stops and restarts. That was a real issue with Glue, right? And the Spring Cloud data flow didn't have a clear description as to how it managed it. It sounds like you'd have to write it. Managing failures and duplicates. Again, the Spark Structure Streaming, we really like the checkpointing. Again, data flow didn't seem to manage that well for us. And then Apache NIFI, very effective. How secure was it? Apache NIFI seemed to use Kerberos. And if you use Kerberos, it's pretty secure, right? And it's really secure, like if you're a developer and you want to look at the data. Like Kerberos is a pain in the rear. So it was a con for me. It secures your data, right, from everyone. Like, oh yeah, it's secure because no one can see it. Again, the using Yarn and Mesos was an issue with NIFI. NIFI basically said we're going to manage the cluster ourselves, and that was an issue for us. Maturity of the product. Spark Structure Streaming I still would classify it as a really mature product. I found Apache NIFI very mature. Does anyone know the history of NIFI? NIFI was developed by the NSA. And they had been using it internally for some time before they open sourced it. So it was a pretty effective tool, and NSA manages very large data sets. The extraction issue is, how do I extract the data, right? Versus transformation versus loading it. They were all very effective at this. We found that pretty effective. Transformation, again, comes back to this RDD concept, right? If it can be broken into pieces and live through the life of the data pipeline in small pieces, that's fine. But when you have to put it into a big piece, big clump of data, and transform that big clump of data, I felt like the RDD concept was superior from a Spark perspective. Loading data, that was an issue with Spring Cloud, right? But everyone pretty much does it and does it well, and in a known way. The machine learning, I can't tell that NIFI even attempts it other than you can have a node that does it. right? But it's not really a core part of the system. Whereas I felt like Glue and Spark Structured Streaming would support it, right? I actually would give this a con now that I've actually lived with it. Like Spark Structured Streaming has its limitations, and I think one of them is machine learning. Like we did, while our machine learning is done in a batch format. So at the end of the day, we ended up with Spark Structured Streaming. I'm not 100% sure we made the best choice. I think NIFI might have been a better choice because as we're getting more pipelines and adding more pipelines, understanding how it all flows and having a clear description of it is a struggle, right? Which that maybe I go back to the data cataloging issue. If the data catalog solves that problem for me, that would be interesting, which is something we're exploring now. So, any thoughts? Who wants a data pipeline now? Can't wait. Yeah? 7-Eleven wants a data pipeline? Who thinks, oh, what tool did you think, yeah, that makes sense for me? Thoughts? What did you think? 7-Eleven? What did you think what tool sounds best?
Well, yeah, if I had to choose right now, it would be one of the inputs, it would be the Spark Structure.
Okay.
But, yeah, we're just building from the ground up, we're just starting. We have a new vice president, he's on fire,
Okay.
move us into the data age.
Okay. Good.
So, this type of stuff, I think, is very cheap.
Okay. Yeah. Cool. What do you guys use at Exaptive? Do you have a data pipeline? Do you do data pipelining?
Something that's handling enough volume that's to be too big of an issue. Usually that's already done. We're just plugging into whatever that company's already done.
Okay.
So, yeah, nothing sufficiently intense. We're using like a lot of lambda stuff. Anyway, usually things are nothing terribly intense. Usually that's already done by the process.
Okay. Cool. All right. Any more questions? Yeah.
I have a question for you. I'm just judging you by some of the comments that you said. Doesn't sound like you really got that deeply into NIFI.
No. We explored it from an evaluation perspective. Played a little bit with it, but no, I didn't get into it.
Judging by your slide, you have more cons against that than any of the other.
Apache NIFI?
Yeah, I thought so. And like
Yeah.
I said, maybe I kind of went through the slides and I didn't really see. But my point is, the point that I was getting to though is how much have you talked to Luz since you said that they're using it, and will they be able to convince you to switch?
They might be able to convince me to switch. Now, whether they can convince Sonic to switch would be a completely different question. Yeah, we could discuss it. I think the pain has to get a little worse. So I think as we continue to add more pipelines to our system, and then we begin and they begin running over each other, and it begins to become confusing, I think that would be an interesting discussion, right? But then I'd have to evaluate Waterline as a data catalog and see if that begins to solve my description problem, right? How do I graphically look at the way my pipelines are working and running? So.
How portable it is if you move from Spark Structure to NIFI?
Actually, I think it would be really portable because each node you could say, hey, run this Spark job, right? So I've got this Spark SQL that does this transformation, right? So I could theoretically put that then in a node or even split it into more reusable pieces and put it in separate nodes, right? So I think it's actually pretty movable, right? And then the structured streaming part, right, would be managed by Apache NIFI. But the actual SQL transformations done on the data sets or the data frames could easily be run inside of Apache NIFI. Huh? Then I should switch. I should switch. You heard him, Matt. Maybe we can convince. John and Joe to? Okay. All right. All right. What about stream sets? Like, would it be easy to move to a NIFI or something like that? You don't know, you haven't used
I'm pretty confident our guys can move anything,
it. Okay. That's cool.
but I mean, it's smart.
It's more what? I'm sorry.
I think it runs Spark underneath, so.
Oh, does it really? Does it run Spark underneath? You looked at it, didn't you, Kenyatta?
Yeah, but I know a lot of details.
Okay.
I'm kind of, when I'm looking, I'm kind of evaluating Spring Cloud data flow. We write Spring Boot apps, right? That's appealing because we're Java guys, that's what we do. And we're also moving data back and forth between the systems. But I think what's probably going to win out for us is Apache NiFi or stream sets. I think stream sets is kind of come on strong. I'm not surprised it didn't show up because it looked like maybe a year ago, it wasn't as mature as it is now. When I looked at it, I thought it was a commercial product. It was so polished. Their documentation, the website. But I think it's still pretty new. It's got a lot of functionality. I think NiFi's got a lot of appeal, just architecturally how they string together the nodes and the connections are queues. That can be configured to whatever you copy or rather than queue, I think. But that's kind of nice. It's a design pattern that I would follow if I had infinite time. They got it out of the box. So.
Yeah. That is another thing I didn't mention about Spring Cloud, but it appeared that it uses Kafka or RabbitMQ as connectors between data flows, right? So, yeah.
Why do you guys not like Spring and Spring Cloud? Yes.
I'm not a fan.
Okay.
What was the question?
Why don't you like, I mean, almost every job shop I know is using Spring, and some of them are looking at Spring Cloud and stuff. What was it about it that,
Oh, so I have a Spring family. We do use Spring. So we use Spring Boot. That's what powers our microservices. The thing that the appeal, so the way we move data around right now is we use Vue. Part of it is easy. It's easy transition from a Java programmer. It's a graphical interface to lay out how you want to do whatever it is you want to do. It's a little bit more general purpose than what we're actually using it for. We're probably using it for is to move data. So going back to your question about Spring Cloud data flow, I like it. It's got a nice or a decent user interface. It's similar to NiFi, similar to stream sets. It's just not as polished. I don't think yet. And then a lot of the things that I think that you would just get out of the box and from a more product-oriented package like stream sets or NiFi or these processors and endpoints that connect into things easily without having to drop them in code. Which I think getting something off the shelf, people would tend to, I think about a lot of cases that you might not think about baking it. But you also probably get more than what you need. But I think for us, we don't want to spend a lot of time thinking about this. We want to be able to connect and come together and make it work.
does it handle like data overflows and stuff like that?
Which one is this?
For the Spring Cloud?
Oh, okay. So I don't know. I imagine that since a lot of the connections are this is just me thinking about how it would work. I think a lot of the connections are, as Mark said, done in code. You're creating these custom Spring Boot apps that you would have to handle that on code.
I think that was something very similar between NiFi and Spring Cloud is you've got these nodes, right, where you have these defined inputs and outputs controlled by the flow server or NiFi. But the actual the transformation or whatever you're doing with the data is pretty much code you have to write and connect into that node. So, and from a cost perspective, I believe they're all open source free products. Is StreamSets open source? Okay. And one of the reasons that he, and I think to a certain extent Sonic, wants to move off of Mule is licensing costs. Yeah, Mule's not cheap. Right? Okay. Yeah. Yep. All right. Thanks, guys. Any other questions, thoughts? No? All right. Thank you, guys. Lots of pizza.